Matrix multiplication usually begins with this statement about like when you're even allowed to multiply two matrices together. If you think back to yesterday, addition and subtraction, I could only add and subtract if they were the same orders, so that every corresponding entry in one had another entry to add or subtract within the other. That's not the same rule in matrix multiplication. So notice in all of these statements, you're given an order. Okay. Suppose you have some A that is m by n, and B that is n by p. Those are allowed to be multiplied because the columns of A match the rows in B. So see how this one ends with n and this one starts with n? That must be true. And then I can multiply, and my answer, the product A times B, is going to be m by p. So that whole n disappears, and my new order is going to be m by p. So I may multiply two things that are not the same order, and then I may get a brand new matrix that has a totally different order than the other two matrices together. It is possible to get some of the same orders in there, but it doesn't have to be. So on the first slide that I show you, I don't think you need to write anything down yet. This is just to kind of like decide if you can do multiplication. So we're going to put numbers into these things and decide, is it possible to multiply? So don't take the time to write this down. Rather, talk to your pod members and decide what the order of A is and the order of B is. Go ahead and talk to your pod members real quick. What's the order of A and the order of B? Yay, thank you. I appreciate it. Oh, got it. Okay. Josh, what's the order of A?
4 by 1.
4 by 1? 4 rows, 1 column. Charlie, what's the order of B?
1 by 2.
1 by 2. 1 row, 2 columns. I agree. Can you multiply A times B?
Yes.
Yeah, because the columns in A match the rows in B, right? We're looking at this value right here. It has to be the same. So can you multiply? Yes. And the dimensions for A times B is going to be what? 4 by 2, the bookends of those two dimensions. Okay? So A is going to be 4 by 2. Now think about what a 4 by 2 matrix is going to look like. It's going to have 4 rows, and then it's going to have 2 columns. So it's not even going to look like A or B. It's going to be a brand new looking matrix. Go ahead and, again, have a conversation with your pods. This time, do the orders and tell us if we can multiply them. A times B. Okay, Grace, give me the order for A.
3 by 2.
3 by 2.
And 1 by 3.
Oh, and 1 by 3. Logan, can you multiply them? No. Not possible. Maybe I should clarify. A, B is not possible, right? That's what they're asking me about. Now, you might have a discussion with your group. Could you multiply it B times A?
Yes.
Yeah. It will be 1 by 3 times 3 by 2, which will give us a 1 by 2 matrix. Okay, 1 row, 2 columns. So it is possible to multiply one way, and then sometimes you can't multiply the other. Interesting thing to think about. Okay, now we're going to get into actual matrix multiplication. So you want to put this down in your notebook. So you have an example. Okay, so always if I'm asked to do matrix multiplication, I'm going to do the check, can I actually multiply them, right? So I'm going to figure their orders. First one is 2 by 2 square. Second one is 2 by 3. Am I able to multiply those? Yes. And what dimension is or order is my answer going to be?
2 by 3.
Another 2 by 3, so I kind of already know what that looks like. I like to think about this, what my answer is going to look like, because it kind of helps me decide like how many entries I have to have, right? 2 by 3 is going to have 6 entries just like this one. It's going to have 2 rows, and then it's going to have 3 separate columns. Okay, so I know I've got to find an entry for each of those spots. Now, here's where things get a little bit weird because it's a little bit different than addition and subtraction. I'm going to put a little note up here. When I want to multiply matrices, I'm going to multiply each row by each column. And multiply each row by each column. Now, as you do a row by a column, you might have to multiply lots of different numbers depending on how many numbers are in each row and each column. So you multiply like the matching ones, like the first number in the row times the first number in the column. The second number in the row times the second number in the column. The third number in the row times the third number in the column. Keep going, right? As long as you have to. And then after you multiply all those things together, you add them up. And that becomes your single entry. Okay. So you don't always have to write what I'm going to put in here on your paper, but I just want to talk about, like, there are 6 different entries in this matrix. I call it my answer matrix. And where are all of my numbers going to be coming from? Well, this is the first row, first column entry. It comes from taking the first row times the first column. So that's row 1 times column 1. And then this entry right here, this is going to be row 1 times column 2. Because it's the first row, second column entry. And this is going to be row 1 times column 3. So everything that's in my answer matrix in row 1 comes from taking row 1 over here, which is 3 and 1, and multiplying it by each of the 3 columns in the other matrix. The other entries are all in row 2, so they're going to come from row 2. Okay, so then I'll be moving down to 4, -2. This will be row 2 times the first column, row 2 times the second column, row 2 times the third column. And like I said, you don't always have to write that out, but just be aware, if you're ever concerned about an entry, that entry came from that specific row and column being multiplied. Okay, so if you need to go back and check, you can. Okay, so let's get into the actual multiplication, right? Bless you. Okay, remember, up here at the top, we're going to multiply each row by each column. So I'm going to start with row 1, 3, 1. And then I'm going to start with column 1. To multiply the row by the column, I'm essentially going to like turn the row. I imagine like making it vertical. So instead of being 3, 1 horizontally, it's going to be 3, 1 vertically. And then I multiply corresponding entries. So the first entry in the row is 3. Multiply it by the first entry in the column, which is 2. That gives me 6. But there's more entries, so then I have to multiply those and add. So now I take the second entry in the row and multiply it by the second entry in the column, which gives me 1 times 3 is 3. So 6 plus 3, now I'm out of entries in each row and column, right? I'm done. So my first entry in my answer matrix is 9. Well, I gotta take that first row and multiply it by each of the columns. I usually like finish out a whole row. So I'm gonna move to the next column. 1, -2. First entry times first entry. 3 times 1 is 3. Second entry in the row times second entry in the column. That would be 1 times -2. -2. So you could say 3 plus -2, or you could just write 3 minus 2. That gives me 1. How are we feeling about what you're seeing there on the screen? Is that okay?
Not bad.
Okay, and then you still have to do
The other one.
the third column. Okay, third column. So we've done the first row times the first column, the first row times the second column, and now we got to do the first row times the third column. So that's this column right here. First row, first entry in the row times first entry in the column. 3 times 0 is 0, not to be confused with 3. And second entry in the row times second entry in the column. 1 times 4 is 4. Add those together. And so the last entry is 4. Can you do the second row? Try it. Okay. For the second row in the answer matrix, you're going to restart, but instead of using 3 and 1, you're going to use 4 and -2. See if you can give me those numbers. Raise your hand if you're like, what in the world? Maybe talk and check with your group. Do you get the same entry for first, second row, first column?
What'd you use? I got 9, 1, 4, 2, 5. 2. You must have done 4 columns.
Wait, have
So
a
much
sign error in your second row,
I got
second
2.
column.
I might have done that.
Oh, I'll reach it.
It's 4 times 1 is 4
-2.
plus, oh, I see. I for some reason was just thinking that's the one at the top and adding that. Yeah. There we go.
Okay, I'm pretty impressed as I walk around. So I'm going to go ahead and do, and I'm not going to circle everything again. Sometimes you'll see, like, if you're having trouble with this when you're at home tonight, you know, go to YouTube and pick a video. But sometimes you'll see, like, people use their fingers in the video, and they, like, you know, they take a number from a row and match it with their, like, a number from the column, and then they just kind of, like, go down the way. And that can be really helpful because it gives you a visual for that. But I can't really do that all on my smartboard always. Okay. But I'm going to be doing 4 times 2 is 8, and then -2 times 3 is -6. And then I'll do 4 times 1 is 4, -2 times -2 is another 4. And then 4 times 0 is 0. Negative 2 times 4 is negative 8. So as I walked around the room, I saw most people get 2, 8, negative 8, which is our correct answer. You do have to be really careful, like signs, small things where, like, sometimes I see people do 2 times 3 and then they write 5. Ooh, you know, like stuff like that. Or 0 times 4 and people say 4. Okay, so just be really, really careful and make sure that you're doing those things properly. Okay, so multiply if possible. Try this one. I'll leave you to it. Maybe discuss with your pod. Can you multiply it? Should you multiply it? What will your answers be?
The first one is 3 by 2.
Remember when you get to the multiplication part, you gotta like tell yourself how to multiply 2 matrices together. You take a row in the first matrix and you multiply it by the columns in the second.
It's 2.
Should be 10.
So I have mine really big right there because I'm going to be showing.
So loud.
I always show it's more because then if I like have an error or something, so
Figure out what
Negative 2.
so like this has 3 rows.
3 times 3.
So I think there's 2 numbers that add together. Oh, okay. How do I get 3 by 2? So as long as these 2 match. Negative. Yeah.
Yeah. Yeah.
If it would it are you saying 3 by 2 and 2 by 3? Oh yeah,
Negative
so
3 by 2
times
times
yeah, each row by each column, so you take the row multiplied by each column. Yeah, it's better about that.
Wait, you get -6?
negative 6 and 12.
Yeah.
Remember, you're going to take row.
You get 7.
Columns are vertical.
6.
Rows are horizontal. So you're going to do -2 and 3. Yeah, and you're going to multiply that all.
You get negative 6 and 18.
Okay, I got my work for my first line up there. And so then I will be starting my second row. I'll be taking my second row of the first matrix, multiplying it by the columns in the second matrix. So your answer that you have written is a 2 by 3. When you have it labeled as a 3 by 2. So you probably just, I'm guessing you might have the right entries, but maybe they're in the wrong spot. Like a 3 by 2 looks like that, right? You guys all agree on the numbers?
Yeah.
Wait, are you going down or across?
I'm doing across.
I got negative 4, 6, 7, negative 13, negative 6, 1, 2. I don't think I got this one too. Wait, 18 is to negative 6.
One of your other 5 numbers is 6. Do you know where my numbers came from?
Negative 4, 6, I got 7.
How did you get 9? You have a 9 right there?
Yeah, you're right.
You got it?
I got it. Okay, so you take the first row, right? Negative 2, 5, 30, and negative multiply it by negative 1.
Oh, that's a straight line.
So you gotta do row and column for whichever one is the first one. You do the row.
6, 7. That's why
No matter how big they are.
Doesn't have to be like straight line.
Okay, so I'm going to finish out this problem. I'm going to take my second row times my first column here. So 1 times negative 1 is negative 1. Negative 4 times negative 2 is 8. Negative 1 plus 8 gives me 7. And 1 times 3 is 3. Negative 4 times 4 is negative 16. So that's 3 minus 16, which is negative 13. And then finally, to get this last row in my 3 by 2 answer matrix, 3 rows, 2 columns, I'm going to have to move down a row in my multiplication. So now I'm at 6, 0. I'm going to take 6, 0 and multiply it by each of these columns. So 6 will always multiply by the top of the column. 0 will always multiply by the number in the bottom of the column. So that's negative 6 plus 0, which is negative 6. And what is that? 18 plus 0, so that's 18. Negative 6 plus 0. Overall, I think you guys are doing a really good job. I will say this. Things can get easily lost in translation from the smartboard to your desk. Okay? So the best thing you can do is really sit down with your paper. If you get lost, have somebody right now point it out to you or call me over. We just need to see on our own paper right in front of us for our very own eyes what the matrix multiplication is doing.
Okay, I'm just wondering, but what's the biggest matrix we'll see? How many rows?
I would say probably 3 by 3 would be the largest. I cannot guarantee that. That's what I would say. Okay, so I'm going to actually give you some time right now to work on the matrix multiplication because this can be tricky for some of us.